If you take a relay out, you don't know what effect that's going to have on the operation of the vehicle. It might even affect the circuit that you're trying to diagnose. And if you pull a monitored relay out, you'll set a DTC.
Dave's absolutely right. Removing a monitored relay will set codes and may prevent further testing of the circuit. There is no difference between a monitored or passive relay. It's the circuitry within the control module where things change. These monitored relay circuits will detect shorts to voltage or ground, opens or excess resistance, and then set the appropriate diagnostic trouble codes. If presented with any of these DTCs, all test procedures must be carried out with the relay in place, with the exception of terminal tension. With the relay removed, the control module may disable the circuit, preventing accurate diagnosis. A relay jumper, a strong knowledge of automotive relays, and a wiring diagram is essential for checking these circuits. Most standard automotive relays are labelled with pins 30 and 87 for the load side, and 85 and 86 for the control side. But now we are seeing more and more mini and micro relays fitted to vehicles. The labelling is slightly different. Terminals 3 and 4 are now the load side, with terminals 1 and 2 for the control. The schematic shows a changeover relay with terminal 30 connected to battery positive and terminals 87 and 87A attached to the load. On the control side, terminal 86 is connected to chassis ground, while terminal 85 receives a signal from a driver in the BCM. This is a high-side controlled relay circuit. What's different about this circuit is the processor can assess the integrity of the control side using a pull-down monitor. The processor is able to monitor the control circuit for faults when it's active and inactive. With no command to activate the driver, the processor should see 0 volts at the monitored point. When the driver is activated, the circuit is pulled high. Current flows through the driver, activating the relay. The processor should now see 12 volts at the monitored point. So now we know the processor expects to see 12 volts when the relay has been activated and 0 volts when deactivated. A short to ground in the relay coil circuit can only be detected by the processor when the relay has been activated. The processor knows it should see 12 volts at the monitored point, but with the short to ground in the circuit, it will continue to see 0. A short to ground DTC will be logged. A short to voltage can only be recorded when the relay has been deactivated. In this state, the processor expects to see 0 volts, as influenced by the pull-down resistor. If there is any other voltage at the monitored point, a short to voltage DTC will be set. If the processor sees significantly less than 12 volts when the relay is active, a DTC relating to circuit resistance will be recorded. The resistance may be due to a poor earth point, terminal tension, corrosion in connectors, or even the relay itself. The diagnostic procedure for a low side control relay circuit is a little different. This type has battery or ignition voltage supplied to terminal 85 of the relay circuit, with the ground path completed via the low side driver within the control module. To activate the relay, the processor applies current to the base of the NPN transistor, thereby allowing a ground path for the control side of the relay. Feedback is achieved using a pull-up monitored circuit. With the relay activated, the processor should see 0 volts at the monitored point. With the relay deactivated, the processor should see 12 volts at the monitored point. A short to ground can only be detected when the relay is deactivated. The processor should see ignition voltage, but if there is a short to ground in the relay control circuit, the processor will see 0 volts at the monitored point. In this instance, a short to ground DTC would be logged. DTCs relating to opens in the relay control circuit can again only be detected if the relay is deactivated. The processor expects to see 12 volts in this state, but an open will result in only 5 volts from the pull-up resistor. Excess resistance in the control side can only be detected if the relay is inactive. If the reading at the monitored point is higher than 5 but less than 12 volts in this open state, then the processor will record an excess resistance or even a signal performance DTC. When diagnosing monitored relay control circuits, the relay must remain in place, otherwise your test results will be incorrect. And remember, training now will prepare you for the future. Thanks for watching.